year, so I'll be very happy that you are so confident about. Now the other form of that equation of motion that we told, one is that work energy, other is this form. Now this popular form you know from your schools. What is the name of this form?
Impulse.
Impulse momentum theorem.
Impulse momentum. So in some problems you will find this method is very useful, where work energy and the conventional force is equal to mass multiplied by acceleration. Compared to those, you will find this, particularly when we deal with impact problems. Okay. Now, for very small time duration, if there is any force acting in that system, so calculate this, or if some force versus time graph is given. So there we integrate or calculate graphically the area. It will be the net change in momentum from initial configuration to the final configuration. And if forces are in the form of action reaction, then a very simple example like this. Suppose two boats are there, connected by a rope, and you are sitting on one boat. The mass of this system is ma. Velocity, initially there is no velocity, suppose, and here there is also no velocity. Simply these two boats are floating on a still water body, and you are holding that rope. Now you apply some pull there to bring the second boat nearer to you. Now what about the forces acting in this rope? It is in the form of action and reaction. So whatever may be the value of this integral f dt over that time span t1 to t2, for action as well as for the reaction, those are same and nullifying each other. And if these are the velocities for this boat A and for this boat B, finally after a certain time, and VA dash and VB dash, if these are the velocities, so final momentum MA VA dash for this boat A and MB VB dash for the boat B. So this kind of problem, when really we cannot find that force is equal to mass multiplied by acceleration, such kind of thing, or work energy. So this will be useful for such things. And some more examples definitely you have done in your school, that is the impact. So that is also a very useful application of this method, impulse momentum. Okay. Now when we consider this impact, suppose two spheres are there, they may be heavy, they may be lighter, centers are at location A and at location B. This is the location where these two spheres are colliding, and if we join two lines, rather these two centers with a line, that center line and the velocities before impact, they are corresponding to that line. Normally it is called that central impact, but direct central impact. And for this kind of cases, this line velocities before impact, these are not along this line like the previous case, is the oblique central impact. Now whatever may be the situation, the impulse and momentum, those things are to be considered particularly at this location. For a small span of time, very small span of time, they collide and then they get separated. And during this period, that impulse in the form of action and reaction will give us the net change in momentum. So before impact and after impact, those will be same as if it is this kind of action reaction form in this rope. And during this contact, that mechanism is very complicated. Now, can you tell me how we can find out the time of contact, or what is the force developed at this contact location?
We can find out momentum with change in momentum.
Momentum, sir. So you can find the momentum, sir.
Okay. For momentum, you need to find out the velocities.
Yes, sir.
So before and after impact, we should have some, maybe some high-speed photography method or some other thing. So just hold for 1 second. I'll do that.
Sir, you are muted, I think.
Sorry, I don't know how it happened. So for that temporary, it may be shoot-like thing. The temporary paint, for different velocities of impact, that portion will be smaller or bigger depending on the more velocity of impact or smaller velocity of impact, etc. So that approaching relative velocities. And by static load test, just apply some load and find the area of contact. Naturally, there would be some deformation. That is another part. We will come back. But it is very primitive and primary measurement method. Just getting the area where from that temporary paint has been removed during this impact and calibrate it with that static load which is required to give that area of removal of the temporary paint. But now we do not do in that way. There are so many electronic devices, very modern and improved. Okay, and that is one part. Other is definitely you can say that some material property is also involved. Okay. Now in mechanics, normally engineering mechanics, normally we do not consider the material property normally, that its ability of deformation. But when we consider this impact problem, naturally, partially we have to know about the material property. At least after collision, they will stick to each other or they will be separated without having any permanent impression or permanent deformation or distortion of the shape of these two spheres, or there will be some change in their shape. So you know these three names of these three types of impact. Can anybody just remember and tell me?
Elastic, non-elastic.
Non-elastic
Perfectly
normally,
elastic,
yes.
perfectly elastic and partially elastic.
So either after remount, they will regain its original shape, that is perfectly elastic, or they will deform and stick to each other and travel with a common velocity after impact. There is a perfectly plastic collision, and something in between, some permanent deformation or distortion in the shape of these two spheres, it occurs. So for perfectly plastic, the final velocity will be common for both the things. So initial momentum for the system is the MAVA plus MBVB. Of course, direction we obviously consider. And after impact, MA plus MB multiplied by the final velocity V, that is one thing. Or for perfectly elastic collision, there is no loss of energy. So naturally, you can simplify the situation with that popularly known as the simple transfer of velocities. But whenever it is in between, some relation is there, some coefficient. Now, what about that name of the coefficient? That also, just try to remember and tell me.
The coefficient of restitution.
And what about that expression?
Separation by approach.
E2 minus B1 by U2 minus V1 equal to minus E.
Is the ratio of relative velocities of the objects after and before impact. Is it not?
Yes, sir.
Yes, sir.
But how we know that thing? For that, definitely lots of experiments we need to do, and during this time we are having all these advanced system of measurement, etc. But when these things, these ideas are there in those great people's mind, necessarily they did not have that facility. Okay. Now, have you heard the name of professor or the great scientist or physicist Jagadish Chandra Bose?
Yes, sir.
Yes, sir.
Now, in different areas, he has done lots of contribution in physics. Now, most popularly, it is normally mentioned about him that he proved that there is some life in yeah,
Plant. Trees, plants.
exactly.
Plant.
Now, what about the experiments? How could he prove? It was so crude and it was so crude and rudimentary that even in modern days we'll simply laugh at those instruments. But at that time, it was magnificent. Okay. Anyway, he was not so fortunate to get that popularity in a form of that material gain, in the form of what you normally say, that patent, that type of thing. Even that what normally today Professor Marconi is famous, we know what happened. Okay. Anyway.
Politics.
प्लीज आज कुछ अच्छा दिन है. It is Women's Day, so all my girl student in my class, I wish my all the best for you in this, and all of us, we must take proper care for their independence, for their movement, particularly in our family. what I feel, our mothers are normally most, even if we call it neglected, we do not use that word, but at least we can say whatever they are doing, they are not recognized. Okay. Abibi, we differentiate between our sons and daughters. It should not happen. Anyway, so all these things that we know we utilize for the direct central impact, the oblique central impact for different situation and combinations. And this is, in short, yeah, before impact with the velocities at maximum deformation, they collide. Obviously, VV must be less than VA so that they collide. And during impact, there will be gradually more and more deformation at this contact location. And finally, they get separated with the final velocities of A and B. And when these pair of forces, action reaction of same value acting for the same period of time, so the total momentum before impact and total momentum after impact, they will be same, because integral f dt from t1 to t2, it is 0. Now there are so many applications of this, very simple, but from this single equation you cannot find or you cannot solve the final two velocities of A and B. So what about the other equation?
Sir, coefficient of restitution.
Coefficient of restitution, if it is semi-elastic, if it is perfectly elastic, then there is no loss of energy. And if there is perfectly plastic impact, in that case, there is no separate existence of VA dash and VB dash. It will be a common velocity. Suppose it is V. So MA VA plus MB VB is equal to MA plus MB multiplied by V. So for these three distinct situations, we can utilize either the common velocity for plastic impact or the perfectly elastic impact, that is simple rebound exchanging their velocities in opposite directions, or it's a combination in between that using the coefficient of restitution. So we need to find out another relation where the relation between the velocities or this final velocities in this standard form or in the form of no loss in energy. So if there is no loss in energy like perfect elastic impact, then half ma va square plus half mb vb square is equal to half ma va dash square plus half mb vb dash square, and change the sides. So va dash square minus va square, that is equal to mb multiplied half mb multiplied by vb square minus vb dash square. And you just remember the formula, a square minus b square is equal to a plus b minus a plus b multiplied by a minus b. So naturally you can simplify that and getting another relation. So from these two equations you can solve two unknowns. Now there are some very interesting example where we can combine the energy method and this impulse method. This red sphere, it is hanging freely. Here is another sphere connected to this rope. It is rather stretched. Stretched means it is taut. That means there is no initial tension in this rope. It is acting like a pendulum. Now you release it. And the sizes of these two spheres are such that it can simply reach here. When these two things are in their static equilibrium and hanging freely, they can simply touch without providing any other force there. But when it is allowed to fall in this way, naturally with this restriction of this length, it will travel in this circular path and finally it reaches some velocity. Now initial velocity for block A is 0. Final velocity for block A is VA2, and with this initial velocity, it hits this red sphere and there will be impact. Now, depending on whether it will be plastic impact or elastic, perfectly elastic impact or something in between, we need to solve accordingly. That part is under this impact, and after impact, they will get separated. And when we are asked to find out what is the final height that the sphere B can gain, this red sphere can attain, so there we utilize that conservation of energy. So not necessarily we need to use that integral f dt from t1 to t2 that is equal to m v2 minus m v1, that in that rigid manner. The problem may be like this also. Now, one thing, idea is simple and same, but problem may be, just to test us, it may be of different manners. Suppose this ceiling is not holding these two spheres A1 and these two spheres A and B with the same length of rope. Suppose what we can do, just hold a minute. Sorry. Suppose it is like this. So naturally, when it swings and colliding with this red sphere, that is B, naturally the velocity, it depends on this length of swing. Okay, it may be like that, or it may so happen the ceiling for this block A or the sphere A, it is fixed, it is here, but for sphere B it is different. Now in this case, before impact, the A having some velocity giving some higher kinetic energy, and that kinetic energy when it is transmitted or transferred, naturally it travels maybe some greater height compared to this or greater angle of swing. Even if it reaches here, it becomes horizontal, then also the height traveled may or may not be same like this. It may swing further. So it depends on the situation, but primarily the total energy to be conserved if it is perfectly elastic impact. So this kind of situation definitely you have handled earlier. Another such example. Anyway, before going to the problem statement, we just try to understand. Here is a spring. One 10 kg mass is placed there. Just slowly, you just place it here and finally it compresses. Then you take one 30 kg mass at a distance of 2 meters and allow it to fall freely over this platform having the mass 10 kg. The problem statement is like this. A 30 kg block is dropped from a height of 2 meters onto the 10 kg pan of a spring scale. Assuming the impact to be perfectly plastic, determine the maximum deflection of the pan. The constant of the spring is K, 20 kilonewton per meter. Now this thing is very important. The impact to be perfectly plastic. Now initially could be when there is no such mass of 10 kg, that pan is not there. Okay. Now, have you seen the digital scale in market? कभी कभी बाजार में जाते हो कि नहीं? Or 24 hours you are with your books only?
No, sir.
So how
24 hours in bazaar.
24 hour in the market?
Yes, sir.
Okay. अच्छा लगा सुन के. कोई तो है. Not too much serious about your.
You mean perfectly inelastic body in case or plastic?
Now suppose we have some potatoes here and we want to weigh that. So normally you will find it is connected to some power. This is removable pen. So initially when no pen to hold those materials, the potato or whatever may be the vegetables or maybe some object, it is there. If it is not there, this pen is not there and it is showing 0 in the digital screen. Okay. Then what we do? We place the pen. When you place this pen, definitely it will show this mass. Naturally, in terms of mass or weight or whatever it has been calibrated, it will show this when it is placed and there is some compression. Now, if we want to find out the mass of some vegetable, what do you do? They do something. Have you noticed? They place the pen weight is shown here, and we want to find out the net weight of the vegetable. How to do it? Naturally, if that 30 kg vegetable is placed over this spring now, it will show 40 kg. Digitally, what they do? What operation?
सर उसको फिर 0 पर ले जाते हैं.
Exactly. इसको 0 कर देते हैं. So that part is electronically it is there in your hand. So make 10 is equal to 0. So with reference to 0, now this 40 will become 30. But that spring on which this object is placed, the 10 kg pen, definitely it is providing this compression. Now what about the value of this initial compression? From this 20 kilonewton per meter. Now what about 10 kg? It is equivalent to
10 by 10 G by 20.
10.92
20,000.
10 to 9.81
20,000.
Newton. So 10 multiplied by 9.81 divided by 1000 kilonewton. So it will give kilonewton. So per 20 kilonewton there will be 1 meter deformation. So that divided by 20 kilonewton, those many meters. So that initial deflection, initial deformation is very important. It is one thing. Then this graph, if some maximum deformation when the 30 kg block is over it, what about the final compression or this additional compression? The final compression with respect to this, it will be 40 multiplied by 9.81 divided by 1000, that divided by 20 kilonewton, and that in meter. Now for 10, it is somewhere here. For 40, it is somewhere here. Now the total work done during this additional deformation will be the area of this part. So this simple thing we need to remember. Remaining part is exactly similar to whatever you have done earlier, but we can combine that like the previous problem here, the conservation of energy part, then impact part, then again conservation of energy. And
maximum
assuming
deflection will be more na.
maximum deflection will be
More na, because it will
maximum
extend
deflection
that
will be more, but we are talking about if we simply place this 30 kg block on this span 10 kg, simply we place in and gradually you remove your fingers from holding that block of 30 kg, and it as if some quasi-static deformation is there. Very slowly it is coming down, coming down, coming down, coming down, etc. So that 40 multiplied by 9.81, that divided by 1000 kilonewton, that divided by 20, that is in meter, that is the maximum static compression. Okay, but this additional part need to be considered separately. How, that we'll discuss. Now let us clean to have some extra space to write. Now this thing is important. Impact to be perfectly plastic. Maybe this was the level undeformed. This level when the 10 kg mass is there, we have been given this situation, the second one. Next thing, this 30 kg mass is allowed to fall from certain height. Now we consider just before impact, other just above this, this is almost zero, this gap. So when this 30 kg mass is coming down and reaches this level, upper level, just before touching the 10 kg mass, then simply from that conservation of energy, as it is traveling through some obstructionless medium, suppose air is not providing any resistance due to friction, etc., or whatever may be the other thing. So we can find out the velocity of this 30 kg mass just before impact here.
So root 2 GH.
Okay. Then that energy to be transferred to this 10 kg block, and the total system will travel in a combination. That means if it is the final deformation so from that maximum velocity to this, or from this level to this level, the bottom level of that 30 kg mass before impact and bottom level of this 30 kg mass at maximum deflection, or simply the top of the other free end of this spring before impact and free end of the spring after impact, whatever we like to define it, the things will be such that there is a combination of movement in this plastic impact. Final velocity is zero. combination of these two masses, that ultimate final velocity is 0. And what about that energy? It is traveling with some initial velocity, square root twice gh, final velocity is 0. The combination of masses 10 plus 30, it is traveling from that initial velocity to reach up to this. So combination of this first part, the plastic impact part, to have the final velocity, and then for that spring obstruction, it reaches to some 0 velocity, and at that 0 velocity we need to find out the maximum deflection delta max in addition to this. So either simply this or include this, that is the total deformation of the spring. Whatever it is asked, you have to consider the 3 phases separately. First phase, simple calculation of velocity using that kinetic energy change and the work done due to gravity force. Then that energy to be conveyed to the system, and finally that comes to 0. So that work done during this movement or that plastic impact. So all these small components we need to consider and do these things very carefully. Okay. Now, if by any chance there is a possibility that some rebound is possible, that means it is not perfectly plastic. So necessarily what we need to do, that it rebounds, moves back, and it transfers some energy, it gives some relative initial velocity, and that initial velocity of 10 kg mass to be brought back to 0 velocity at the maximum deformation of the spring, but without considering the possibility of this 30 kg mass after it bounces back and suddenly it reaches its maximum height and it starts falling down, and again it provides some impact. So that part is not considered. It will be another issue. So similar such things, and you can remember the bouncing of the sphere, it may be like the tennis ball, it may be like any hardened steel ball or whatever it may be. Either it is perfectly elastic impact or semi-elastic. And remember this kind of problem. So gradually it will come down, the maximum height attained. So please do some practice on this application of impulse, momentum, impact, direct central impact, and combination of all this work energy principle and this impulse momentum method. Okay, so please do it, and you can take a screenshot of this. Sorry, it is now that full page of. Oh. No. So please take a screenshot and check those, because there is a possibility books can also give some mistake, either the printing error or calculation error. But when you finish it, just tell me, I'll take your attendance. Done?
Done, sir.
Okay.
Done, sir.
Just hold a minute. Just I take your attendance, then I will give attention to you. Okay, it's done. So do you have any question?
sir.
Now, so okay, let us stop here today because at 11, I don't know whether you have a class or not. But anyway, stop here today and please
Yes,
do
sir.
some problem for your practice.